So I just wanted to spend a quick minute. So you had Tuesday was a project work day. So you should have been kind of working on your process flow diagram and the table that goes with that. And so that's due Monday night at the end of the day on Monday. So make sure you get that turned in on time. Again, it's got the 20% penalty if you turn it in late. So it's well worth it to get it done and get it turned in on time. And then we'll cover chapter 5 next week. We'll have 3 lectures over chapter 5, 1 today, 2 for next week, and then we'll come back in on that following Tuesday and do the exam review. Then Dr. Super's going to come in on that Thursday, and she's going to be here to proctor the exam. I think, did I tell you my mom had knee surgery? So she had both knees operated on, and so she's in rehab right now, and so should be in there for a couple weeks and should be coming out about the time that I fly out. So so that's the reason why Dr. Super will be here. Then we'll come back from spring break, and you'll have a couple of days, so we won't have class, Abby, Julie. We won't have class, just because I say that because they were here on Tuesday for class. They were
ready to go.
Yeah, they love this class so much that they just had to come by. That's my story, and I'm sticking to it. So that Tuesday and Thursday after, you'll need to be working on Project C. I again will be in the office, so it's a great time to come by and ask questions about it. Don't wait until the Sunday night before it's due to try to figure it out, because that you won't have enough time if you've got to go back and get more data. So I encourage you to be proactive about that. And then, so really, spring break, and then I won't see you unless you come, and I hope you come see me and ask questions about your project, but I may not see you then until that April 4th when we come back. And we're going to do kind of a quick overview of chapters 6 and 7. But what you'll note is they're just going to be informational. I am not going to be testing you over that, because I want you to have that as an overview, but we don't have, so it was kind of a choice of, do I give you time off to work on Project C, and we go ahead and keep working on chapters 6 and 7 and take a deeper dive on those? And I don't think that we need a deeper dive. I think you need to have the overview. I think it's more value added for you to be working on your projects than it is to be it's inventory analysis and safety inventory. And the reason I say that is I want to present it from this text perspective, but you get that in 2 other logistics and supply chain classes. So, you get it in the foundational class, and then I think you get some of it in Dr. North's class as well. So, so that's kind of where we're at and where we're headed. What you see is, we've been pretty busy with keeping up with the goal, and you should be finishing up the goal as well. If you don't have it done, that's one that I know I'm not following the late penalty on the goal stuff, but you need to go ahead and get that finished up. So when you come back after spring break, right, you should feel things kind of lighten up for you, right? So you're not having to do the goal on top of what we're already working on. And then we're going to cover basically chapters 8 and 9 before the end of the semester. And we're going to go into the end of the semester, and basically the exam will be that April 27th over chapters 8 and 9, and then you'll have time to work on your projects. We won't be having class on these couple of days, on that Tuesday, Thursday, and one of the reasons why the class is set up this way is because I actually am at a conference that week. So I can be available via email, but I actually won't be in the classroom. So that's kind of, you'll have a little bit of time to finish up your project, and then during finals week I'll ask you to do just meet with me one-on-one to do a presentation, I think is what we'll do. Or we may just meet during our 2-hour window and have you do the presentations then. I think that might be our best bet. So that way other people get to see those presentations too. So what I did realize is that I haven't done a very good job of explaining what for the presentation for B, because that's part of B. So I'm going to go ahead and extend the due date on it by a week, but I'm going to tell you what my expectations are on that, and I'll try to get those formalized and out on Canvas. So, so what I'm looking for is if you remember, we talked about this early on, is when you're writing your paper, you're providing me the level of detail so that I can verify that you have calculated things correctly, and I can look and make sure that things tie together like what they should when you're doing a continuous improvement project, okay? When you present to a client, right? So let's say Austin, let's use the example. We were talking about this on Tuesday. So when Austin talks to his rowing team about his project, they're not going to care how he calculated inventory, right? They just want to know what's important to us. What's the meat that we need to take away from this, and how are we going to address it? And so, like for part B, that's going to come in. You want to show the diagram as it currently exists. And Abby, this is why you kind of want to put the information on the diagram, is because that's what you're showing to someone else. Your chart that you made, that helps me a ton, but that doesn't necessarily help somebody that doesn't know why you've done it that way, right? So it's your chart that is going to communicate to your client why things are the way they are. Okay, and so we have a lot of time at these different steps, or this is the percentage of throughput that goes across these different paths. Okay, and so that's why it's important to get that path, that diagram done well, right? Because that's probably what you're going to use in your presentation as opposed to your chart. Okay, charts for me, so I can make sure that you've dotted your I's and crossed your T's there. And then in chapter 3, right, you're supposed to address. At the end of chapter 3, it asks you to address. Is it the end of chapter 3? No, it'll probably be in chapter 4. So when we get, so you may not have as much this time out, but when you get to the end of chapter 4, right, you've got these levers for managing theoretical flow time. And in the paper, you have to address every single one and tell me, here it is, but it doesn't apply, and here's why it doesn't apply, right? Well, you're not going to tell your client that, right? You're not going to go, well, this is a lever, but it doesn't apply to this project. You're just going to pick the ones that apply to your project and share that, via your PowerPoint. So what you're trying to do is just make sure you're communicating the key points from what you're doing. And it's important to understand your audience, because it's that same way. Like oftentimes when I presented to my plant manager, the level of detail that I needed to have to go through with my plant manager was much higher than it was when we presented to executives. Because the executive's assumption is, you've done the homework and you've done it right. I'm not checking that. That's not my job to check that. And so again, the level of detail that you present, continues to just get, what are the key points, right? We're not trying to get into the nitty gritty. So does that make sense about where we're headed with those presentations? And so then the goal is as you do presentation B, presentation C, and presentation D, and I give you feedback on those pieces, when you come to the end of the semester, it's no big deal to put that last presentation together, because you've done the individual components as we go along throughout the semester, and you've got feedback for what revisions you might want to do to make it real quality for the end. So any questions about that project or where we're headed with that? Okay. All right, so today we're going to start in on chapter 5, which is about flow rate and capacity analysis. And if you remember, when I use that lean book that I bring in, they talk about that difference between when you look at flow unit efficiency and resource efficiency, right? And so what we're starting to do in chapter 5 is we're starting to take a look at more resource efficiency. What's our capacity and what's our resource efficiency based on that? So, they're not, they don't always go hand in hand, right? But you need to be aware of both your flow efficiency and your resource efficiency, and you try to make the most out of both of them, okay? Right, so, so in terms of chapter 5, we're, again, flow rate and capacity analysis. And the example at the beginning of chapter 5 is about the demand for cars in China. And let me just flip back to that for a quick second. So, this is a little bit outdated, but it's estimated to increase at over 20% per year in 2010 and beyond. Okay, so car manufacturers are investing billions of dollars in plant, equipment, and personnel in order to expand their production capacity. Toyota had expected sales of over 800,000 cars in 2010 and is counting on its new plant in Changchun province to go online in 2012 to be able to do 100,000 cars per year. Okay, and so what they're getting at is they're going to have this explosion in demand, and they're trying to make sure that they've got the capacity to match that, right? So they've had to do some things. Just to, on that specific example, it must have been in, let me think for a second, maybe 2011, I think. 2012, I actually had the chance to go to China. And it was really interesting. There were a couple of things about it. One, just unrelated to the car example, but people tell you that there are a lot of people in China, and you think you get that. And then, when I went to Beijing, and Beijing is 32 million people in Beijing, right? And, okay, so I'm thinking that's a lot. And then we're going to go tour the, what's the name of the place where the terracotta soldiers are? Anyway, I'm thinking it's in country, and it'll be like Des Moines, Iowa. That's what I'm thinking. And we get there, and it's 8 million people, right? And it's just this, everywhere you go, I'm thinking, okay, well, this will be, no, it's like millions of people in all of these cities. And the other thing that was scary was we took a tour on the Yangtze River, and there are absolutely no birds. They're gone, right? They had some of that, the bird flu, and anyway, there's no birds. You're going down the river, and there's just nothing. And the river is like, you would not want to put your big toe in it, because you would be afraid it was going to fall off when you stepped back. But they've got this huge amount of growth going on, and so this is what happens when you get older. You start to forget the names of things. One of the things that my son wanted to tour, so we kind of tried to pick, okay, everybody kind of say, what's the thing that you would most want to see? Because the reality is we're probably not going back. I mean, it's a long ways, and there's a lot of other places in the world to see. But he wanted to see the dam, the Three Gorges Dam. And so we did the river tour and went to the Three Gorges Dam. And when they built that, they thought that it would solve their electrical problems. And what happened is, after they built it, they realized that it isn't even hardly going to put a dent in those problems, because they're just growing that rapidly. And so there's just a lot of things going on over there. And so, you've heard about the smog that they have, right? And so what they attempt to do is they tell you, if your license plate ends in an odd number, you can't drive on Monday, Wednesday, Friday, and if it ends in an even number, you can't drive that on Tuesday, Thursday, right? So do you know what people do to get around that? They get another car with a different license plate, so that they can, so it's not as though that's really, it probably has for those people that can't really afford to have that extra car, but they're trying to force that, to cut down on traffic. And oh, by the way, has anybody in here ever been to China? So, like, there'll be 6 lanes of traffic, right? Let me just rephrase it. There will be 6 lanes, and there will be 8 or 9 lanes of traffic flowing in and out of those 6 lanes. I mean, it is the freakiest thing I've ever seen. And we were in a taxi going downtown, and we had a relatively young taxi driver, and he got next to a bus, and the bus was just coming over and took the mirror off the side of his car, because he didn't slow down enough to let the bus in. The bus was like, "Yep, I'm just coming over." Nobody stops. I mean, it's an interesting approach. But so I think when they talk about the demand for cars in China, it's just amazing to see that. And then the other thing I would tell you is that we started out in Beijing, and that's in northern China, and I was there by myself for a day before my family flew in, because I had a conference over there. And so I decided I was going to walk to find a grocery store, because I wanted peanut butter, right? So I was going to walk to find this grocery store. And I walked, and I had a map, and clearly I'm not Chinese. There was not a single soul that would stop and talk or visit, or, I mean, it was an interesting experience. It was like, they see you, this is their world, and they don't want anything to do with somebody who's not from there, okay? I had a guy on the train that he teaches English in China. He's Chinese, and he wanted me to write my name down so he could, say it and practice. So we were going back and forth, and I said, well, would you write your name down? And you should. He just was like almost paranoid about that. He went, okay. So he did, but then when he got up, it's on my thing, and he reached over and got his name and took it with him. So there's this underlying, what appears to me to be like a concern about, what people are going to do with your information and this engagement thing. And then we ended up in more of a southern city. Give me a second, I'll think of the name of it. It's one of the big ones. And they were much more, they would like run up and want you to take a picture with you. So it's very culturally, and I thought, again, this is about me more than it is about, but I thought, that is amazing. I thought all Chinese people would be the same, right? Okay, let's grow up, right? All Chinese, it would be like saying New York and California, right? New York and Los Angeles are the same, right? They're not, right? So you'd probably get different experiences like that in either one of those. But anyway, it was a really an eye-opening trip, and again, that whole perspective of a lot of people, I thought I understood it, and I had no concept of it until we got there, and just was how many folks were there. Okay, but back to why it matters for Chapter 5. Companies are striving to match their capacity with the expected demand by deploying the appropriate level of resources and by maximizing the effectiveness of which those resources are utilized. So what we're going to do in Chapter 5 is we're going to look at, okay, let's identify resources. Let's make sure we understand what we are referring to when we say that. And then let's look at maybe which resources are our bottlenecks and which resources are maybe most costly, right? And maybe we should think about how we're utilizing those resources in particular. So for a flow rate measurement, we're coming back to throughput, or the average flow rate of a stable process is the average number of flow units that flow through the process per unit of time. And throughput is expressed in terms of flow units per unit of time. Okay, so kind of building off of Chapter 4, the average flow rate of a stable process can be measured by 3 steps, right? We can observe the process, we can measure the number of flow units that are processed by that process over a selected period of time, and then compute the average, okay? Some different terminology is tack time, right? Tack time is something that's used often in manufacturing, okay? Austin, have you heard of tack time before in your studies? Not so much?
No, I've heard of it, but...
Okay, so tack time is the reciprocal of throughput. So if we go back to throughput, right, throughput is flow units per unit of time. Tack time is time per flow unit, okay? And it represents the average activity time at each workstation, okay? All right, so let's talk about resources and effective capacity. So activities within a process are performed by both capital and labor resources, okay? So Austin, in your example of the rowing team, you've got the rowers that are coming and they're getting the equipment, right? Mm-hmm. And you also have boats and oars, and if you were short boats and oars, that's going to impact how well you can actually execute what you want to do, right? So each activity can require one or more resource, right? I need both people and I need boats, right, in order to have a rowing practice, and oars, right? And each resource may be allocated to one or more activities. So the example that they use to maybe bring that home is bread making, okay? So if you're making bread, your activities include mixing the ingredients, kneading the dough, forming the loaves, placing them in the oven, and baking them, okay? But a given resource, for instance, a baker, can actually be used for several of those activities, right? So a baker can actually do the mixing, the kneading, and the forming of the dough, okay? Or similarly, a loading of the oven might require multiple resources. So you need both the baker and the oven in order for that to happen, right? So as you're documenting your process, it's not just the process steps, it's what do you have to be able to execute those. And so then we talk about a resource pool is the collection of interchangeable resources that can perform an identical set of activities. So for example, if we're talking about bakers, right? If you have 3 bakers in a bakery, right, they're interchangeable, okay? Maybe they're interchangeable. We're going to assume they are, okay? And so each unit in a resource pool, each baker, is called a resource unit. So it's just some terminology here, okay? So resource unit is one person or one capital resource or one labor resource. It's one resource. And then, so what we typically do is we think about resource efficiency. We look at one resource unit, and then we look at how many resources do we have in the pool, and then that gets us to capacity, right? Because if we know what one can do and we know how many of them we have, then we can convert that into capacity. So that, in the nutshell, is chapter 5, okay? And so that's really what we're going to be working on here. Okay, so our resource pool example, we have 3 flexible bread bakers, and we don't mean that they do yoga, right? We mean that they can do all these different processes, okay? Which can perform any baking activity and would be viewed collectively as a single resource pool, while one baker would be considered a resource unit. On the other hand, if each of the 3 bakers specialized in a separate activity, mixing, kneading, and forming the dough respectively, they're regarded as 3 separate resource pools because they're not interchangeable. They do a different thing consisting of one resource unit. So resource pooling is our ability to combine separate resource pools into a single, more flexible pool that are able to perform several activities. Okay, so what we're going to work on for this first lecture is calculating effective capacity. Okay, and so effective capacity, we need to understand both unit load of a resource unit and effective capacity of a resource unit. Okay, and what I want to make sure is don't get overwhelmed by the 2 paragraphs on the page. Think about what we're actually doing, because what we're doing is not that complicated, okay? So the unit load of a resource unit is the average amount of time required by the resource unit to process one flow unit, given the way the resource is utilized by the process. So in the baking example, we could say, well, how long does it take a baker to load the oven, right? That would be a unit load is the average amount of time required by that resource unit, okay? The effective capacity of the resource unit is the inverse of that, right? We're basically just using a different unit of measure and flipping it, right? So and it represents the maximum sustainable flow rate through the resource unit if it were to be observed in isolation, okay? So we're trying to get to effective capacity. How much could we do? So up above, we're our unit load is a time, right? And effective capacity is, think of it as 1 unit per time, right? You're just taking the inverse of it. And then when we move from that unit, right, then the effective capacity of a resource pool is the sum of the effective capacities for all of those resources. So what happens is we're saying a lot of resources and just make sure that you're thinking about the actual concept. What is it that we're trying to do? So let's look at an example, all right? So in our example, we have a resource unit that's an insurance agent, okay? We're going to look at a flow unit of a filed residential insurance claim. So we're going to assume that on average, the agent spends 12 minutes per claim, okay? That's the unit load, okay? That's how long it takes on average to do one. Therefore, the effective capacity of the resource unit is the inverse of that, or one unit per 12 minutes, right? Or 6, and then you can convert that to 5 claims per hour, okay? And so when I do these problems, and I'm going to encourage you to do this, I set them up in Excel, and I'll show you it, and then basically you learn that you're doing the same thing. You're starting every problem in the same way. And you're starting every problem by identifying the unit load, and then you're converting it to effective capacity by doing the inverse of it, right? And so it's like start here, do this, and then identify how many resources you have, and then you can identify the effective capacity of the entire pool, okay? All right, so let's keep going. So the effective capacity of the resource pool, right? We need to know the unit load at a resource pool and the number of resources. Okay, so the effective capacity of a resource pool is we're going to take how many resources we have and divide it by the average time it takes to do one. Okay, Don't get hung up on the formula. We'll walk through it in Excel here in just a second. So no process can produce output any faster than its bottleneck, and the bottleneck is the slowest resource pool in the entire process. So thus, the effective capacity of the entire process is the effective capacity of the bottleneck. So I'm going to show this to you, and then I'm going to build it in Excel so you can see how we do it. Okay. So example 5.1 in our textbook. There's a health maintenance organization, or an HMO, that provides their customers with all-inclusive medical service for a fixed monthly fee. To secure services, they contract with physicians and hospitals that provide their services on a fee-per-service basis. When members of an HMO receive medical service, the providing physician or hospital submits a claim to the HMO for reimbursement. New Life Finance is a service provider to HMOs. For a small fee, it performs the entire claims processing operation on behalf of the HMO. So processing a physician claim consists of the following operations. Claims billed by physicians arrive by mail and are opened and date stamped by the mailroom clerk. So that is one resource, right? We need a mailroom clerk. And then they're placed into a data entry bin. And then data entry clerks, another resource, enter date stamped applications first in, first out into New Life's claims processing system. Data entry clerks must check claims for proper formatting, and then it goes on to tell us all the things they must do. Okay? So I'm not going to read the details of everything they do. Just know they have steps in their process. And then claims are assigned to a claims processor for initial processing. So then we have another resource. And processed claims are transferred by the system to a claims supervisor for inspection and possible alterations. Claims are returned to their original claim processors, who complete the transaction and issue the instructions to accounts payable for settlement. Okay? So we've just gone through who are our resources in this process, right? Mailroom clerk, data entry clerk, claims processor, and claims supervisor. So the first thing I need to know is, on average, how long does it take to process one claim for each of those resources? Okay? And so it goes on to describe, the process involves 5 steps performed by 4 resource pools. And so then basically you'd start with, okay, I've got the unit load, and so I know it takes a mailroom clerk 1 minute to process a claim. It takes a data entry clerk 5 minutes. It takes a claims processor 8 minutes, and it takes a claims supervisor 2.5. Okay, so I've got, that is going to be, you're going to grab that from the problem. It's going to tell you that in the problem. Then you're going to convert it to effective capacity of a resource unit, and I set up my table headings just like this, so it keeps me honest, right? And so my effective capacity of a resource unit is 1 over the unit load, or 1 over T sub I. So 1 divided by 1 is 1. 1 divided by 5 is 0.2, 1 divided by 8 is 0.13, and 1 divided by 2.5 is 0.4. So that's how many claims per minute each of those resources can process. Okay. Well then, in order to get to what's my capacity of that resource pool, I have to know how many of those resources do I have available. I have 1 mailroom clerk, right? I have 1 data entry clerk. Excuse me, I have 8 data entry clerks. I have 12 claims processors, and I have 5 claims supervisors. And I need to make sure, let me read that to make sure I'm saying that right. Because sometimes, yeah, so you're talking about how many resources are there. We'll just leave it at this. So this is a simple example here. And so basically then you say, well then what's the effective capacity of the entire pool? Well, it's 1 claim per minute times 1 resource gives me 1 claim per minute, right? My data entry clerk can do 0.2 claims per minute times 8 of those, so that tells me that my effective capacity of the pool is 1.6 claims per minute. So you see, it's not hard, it's just walking it through, right? The claims processor then is 0.13 claims per minute times 12, right? Gives me 1.5 claims per minute. And my claims supervisor is 0.4 times 5 of those, gives me 2 claims per minute. Okay, so when we look at that, where's our bottleneck? Where's the bottleneck in that process? The mailroom clerk, right? Because they're only able to do 1 claim per minute. Okay, then you start to think about that, and you think the bottleneck of our process is probably the least expensive person in the resources, right? And so it would make you question whether or not you were maybe looking at this correctly, or maybe, so if you added a mailroom clerk, right, then you automatically go, then your claims processor becomes, and so now you've increased what you can do by 50% just by adding the mailroom clerk, right? And so as what we'll do later on in the chapters, we'll start to identify whether or not financially that makes sense, right? But you look at where your bottleneck is, and well, if you fix the bottleneck, what does that do for you? And how, so, is that going to be worth your while? Okay, and so then if I needed to say how many professionals are required to achieve capacity of, say, 80 claims per hour, do you know how you'd figure that? So what do I need to know? If I want to be able to do 80, let's just look at the mailroom clerk. Okay, so if I wanted to know how many mailroom clerks does it take, how many can the mailroom clerk do right now? With one, how many can they do in an hour?
1. Or 60.
60, right? And so if they can do 60 an hour now, if I needed to know how many would it take to get to 80, how do I get there? It's algebra, right? So you just have to keep thinking it through. How are you going to get there via algebra? So I'll, do it down here. So basically, if I need to be able to do 60, I know that I can do 1 claim per minute, right? And my question is, times how many resources to get to 80 claims, right? And so then I'm going to take my 80 claims per hour. And so I'm going to convert this to 60 claims. Everybody agree I can do that? 60 claims per hour times X equals 80 claims per hour. And so then I'm going to go, X is going to be 80 divided by 60, right? I don't have that math in my head, but that's how we're going to get there, right? And so it's about making that connection with your algebra. Just going, okay, well, this is what I know, so in order to get to what I don't know, I have to just restructure the equation. Okay, so again, not hard, but they just take a little bit to kind of to get through. Okay, let's go ahead and look at the next example. Okay, so throughput of a process might not equal capacity because of external or internal constraints. Therefore, it's important to calculate what your capacity utilization is. Okay, and so our capacity utilization is going to be our throughput of the process divided by the effective capacity of that resource pool. All right, and again, I'm going to show this to you, and then I'm going to do both of these in Excel so you can see how we do it. Okay, this information in this column comes from the previous table. Right, that was the last column in the previous table where we calculated what our effective capacity of the resource pool is. Okay, and so then we know, okay, the effective capacity of a resource pool, if there are 480 minutes in a day, an 8-hour day times 60 minutes, right, the mailroom clerk can do 480. The data entry clerk can do 1.6 times 480. Or 768. The claims processor can do 1.5 times 480 minutes in a day, or 720. And claims supervisors can do 2 times 480, or they can do 960. But our throughput is only 400, right? And so Then to get our capacity utilization, we take our throughput divided by the effective capacity of that resource pool. And the only thing you're doing here is you're converting that effective capacity to the same time period that you're looking at your throughput, right? That's all we're doing. We're going to, so throughput divided by effective capacity, 400 divided by 480 is 83%. 400 divided by 768 is 52%. 400 by 720, 56%. 400 by 960, 42%. So really, when you get to the end of the day, you can tell the mailroom clerk is our bottleneck, right? Because they are the highest in terms of capacity utilization, and that should always be that way. If you identify some as your bottleneck, they're going to have that highest. They're going to have the highest capacity utilization. Okay, so what I'm going to do is I'm just going to open up Excel. And we'll go ahead and set up that problem. And I encourage you to just kind of use that, find a process that works for you. Again, we're in a process class, so find a process that works for you and be sure to use that when you do the setup. Okay, so let's go back to we're going to say we need a resource, we need to know what our resource pools are, right? And we said that we had the mailroom clerk. We said that we had the data entry clerk. We said that we had the claims processor. And we have the claims supervisor. Okay, and so the first thing that I need to know, which should come from the problem, the effective capacity of, sometimes OF, a resource pool, and that is going to be flow units per time. And if we're going to use the vernacular that they use in the textbook, we're going to take C sub I divided by, sorry, that's my bad. I started to go to the next. We need the unit load first. So we need the time per flow unit, right? And that's going to come from the problem. And typically then what I do is I go ahead and put my unit of measure right here. Because if you don't have that and then you start talking about hours later on, right, you're going to have trouble with your outcome. And so what we said is 1 minute per claim for the mailroom clerk, 5 minutes for the data entry clerk, 8 minutes for the claims processor, and 2.5 for the claims supervisor. Okay. All right, so that's typically, you're going to get that from the problem, and then you're going to convert that to effective capacity, right? And effective capacity of a single resource unit, which is going to be your flow time, or your flow unit divided by time. Or again, if we use the vernacular, it's 1 over T sub I. And this is T sub I. Okay. All right, and so then this becomes just 1 divided by this, right? And I can copy that down once I do the formula. Okay, and again, my unit of measure then is claims per minute. Okay, and then from the problem, I need to know how many number of resources I have, or how many units in each resource pool. Number of units in the resource pool. Okay. And we have 1, 8, 12, and 5. And so then I'm going to kind of copy this because I can revise it, probably easier. Effective capacity of a resource pool becomes the number of resources we have, which is C sub I, divided by T sub I, or C sub I times 1 over T sub I. So in this case, for me to get my effective capacity, I'm going to say, sorry, I'll label this. This is C sub I, right? That's the number of resources in the pool. So I'm going to take the number of resources in the pool times the effective capacity, right? So I used, again, this portion of it, the C sub I times T sub I. And all they're saying is you could get that same thing if I did C sub I divided by this, right? I'm going to get the same result. Okay, but we typically talk about it in this way just because we want to understand what the effective capacity of the unit is, and then look at the number of resources in the pool. Okay? All right, so we've now got our effective capacity. We got to that point, and then we said, okay, but what about efficiency? What's our capacity utilization? Okay, so that being said, we know that we have 480 minutes in a day. Okay, 8 hours times 60 minutes gives us 480 minutes in a day. And so if I can do 1 claim per minute, that's 480 minutes, right? So all I'm doing here is just running that math down, 1.6 times 480, 1.5 times 480, okay? And then my capacity utilization. My capacity utilization is equal to my throughput divided by the effective capacity of the resource pool. I know this is wildly exciting to watch, but I want to make sure that you're going to set it up. And the reason you need to do it this way is because it seems really easy here, but we're going to build on it, right? And we're going to start doing some tweaking things. And so when you set it up this way, then it's a lot easier in Excel to copy and paste the table and go, okay, now I'm going to tweak this, right? And it saves you time in the long run. So my throughput, I need to know my claims per day. And we said from the problem that there were 400. And so I'm going to then take my capacity utilization is my throughput divided by my effective capacity. I'm going to change that to percent. And away we go. Okay? So, again, it's just about, this first lecture is about just practicing that setup and kind of getting comfortable with how, people get overwhelmed with all the terminology, and try to break the terminology down into why we're doing what we're doing. And then it's not a big deal, right? Because we're taking time, converting it to effective capacity, multiplying it by the number of resources in the pool to get our effective capacity of the resource pool. And then when we're interested in the capacity utilization, well, we have to know what the effective capacity of that resource pool is in the same unit of measure that our throughput is in. And then we do the calculation, throughput divided by the effective capacity of that resource pool. So it's not, and I say that because it always amazes me then after we get through chapter 5 and I ask people why we're doing, they're not putting it together. They're doing the steps because they want to solve a problem, but they're not understanding why we're doing what we're doing. Okay? All right. So let's go ahead and flip back over here for just a quick minute to chapter 5. Okay. So other factors that can affect capacity. So we're assuming that resources handle the units sequentially or one at a time rather than in load batches. So we're assuming that when we put a loaf of bread in the oven, it's only handling one loaf of bread, right? When we get into the appendices, we'll deal with how we handle it when they're doing batches, okay? We assume that all resources are available for the same amount of time. So that's why we were able to say that we have one mailroom clerk and 5 claims supervisors, or however many there were, right? The reality of it is the complexity that we'll add on in rounds 2 and 3 is we'll start to say, okay, well, the claims supervisor, there are 5 of them, but each of them are only available for 2 hours a day. So then you can't use whole units as you have to convert into how many hours and use the same unit of measure there, okay? And we've ignored the effective setups or switching between products. So, imagine an operating room that needs to be reset between different types of surgery, right? It's got to stop and clean and that kind of a thing. So, again, those issues are addressed in one of the appendices here. And then when we talk about product mix, and we'll work on that in some of the problems, there are certain, we have a tendency to want to think about more is better, but more profitable units are better, right? And so that's one of the things we look at in this chapter is making sure that we're paying attention to not just more is better, but more in relation to how much effort it takes to do it, okay? So in most organizations, sales and marketing makes the product mix decisions, and since such decisions affect the process capacity, which is a major driver of profitability, input from the operations group, which is responsible for production, is required, okay? And then we've got another example 5.3 to look at, okay? In example 5.3, we're talking about the effective capacity for hospital claims, okay? And let me go ahead and just take a quick second and we'll run through 5.3. So assume that in addition to processing physician claims, New Life also handles claims submitted directly by hospitals. The process used to handle hospital claims is the same process for physician claims. However, the unit loads required for the various operations are different. So table 5.3 contrasts the unit loads required for the 2 types. Okay, so this is table 5.3, right? We have the unit load for the physician and the unit load for the hospital. Okay, and so again, 1 minute, a minute, 1.5 minutes, 5 minutes, 6 minutes, 8, 8, 2.5, and 4. So you can see that a hospital claim actually takes more time than the physician claim. Okay, and so what we do is we start out and we calculate the same thing for the unit load for a hospital as what we did for the physician. And I'm not going to walk through that because really all we're doing, we're transferring these numbers into our table, right? And then we're 1 over those numbers. How many resources do we have? And then we're calculating the effective capacity of that resource pool. So again, That's just simple math we're walking through there. Okay? So just be aware that we're going to stop here on day 1 because I don't want to mix anything. I want you to do like a very simplistic approach with the problems on day 1, which are we're just looking at one type of claim, right? And what we'll do when we come back then on Tuesday is we'll combine up the physician and the hospital, because it's really not equitable to look at them separately because we don't have 2 separate resource pools, right? And so when we come back, we'll combine up those different types of claims, and we'll walk through how we address that. But again, so you're just building your knowledge as we go through chapter 5. So what I thought I'd do is I will be here if you want to stick around, you want me to stick around with you, and you've got questions about your project, or if you're done for the day, then we'll be done for the day, and that's good. But that's where I want to stop for today, just to kind of do that dividing line. I want you to get comfortable with a single type of product, and then we'll move into multiple types of products on Tuesday. Any questions? I know it's wildly exciting.